Today, good evening friends. Now I want to explain in regarding periodic properties, one of the important concept, that is electron affinity. One is electron affinity. Now today I want to discuss about the electron affinity. What is electron affinity? If you take any atom, for example, you take this positive charge, any atom, what is the definition? To attract the electron to valence shell. Valence shell. This is a isolated atom. This is isolated atom. What is electron affinity means? Definition: the amount of energy released by addition or attract electron in a gaseous isolated atom. This is important point. The amount of energy released by addition of an electron in a isolated gaseous atom is called electron affinity. It is called electron affinity. The amount of energy released is called electron affinity. For example, the addition of electron must be in the valence shell. This atom should be isolated gaseous atom. Isolated means single atom in gaseous state only. The amount of the electron should be added to in the valence shell only, not inside the atom. The positive is there, that is attract the electrons by addition of this electron in the valence shell isolated gaseous atom is called electron affinity. For example, if you take a isolated and gaseous atom, by addition of any electron, it will release A minus plus electron affinity is this energy release defined as electron affinity. This is the equation. If electron affinity, this is, if we convert it into delta H is equal to minus electron affinity. If it is x kilojoule per mole, x joule per mole, or calorie per mole, you can measure energy any of these units. If you take delta H is minus electron affinity, means if it is x kilojoule per mole, x joule per mole, or minus x calorie per mole. This is the equation. What is electron affinity? The amount of energy released of addition of electron the valence shell in a gaseous isolated atom is called electron affinity. This is the definition. This is the equation. Next, if you take, this is what will happen if you take different conditions. For example, if you take successive electron affinity, successive electron affinities. If you take isolated gaseous atom, by addition of one electron, it will give A minus plus IE1. If you take one, add one more electron, what will happen? A2 minus plus IE2. A2 minus plus addition of electron, this is minus, we have to supply 2, add electron, this is minus IE3. If you take for example, by after adding one electron, If you add to one more electron, it will get repulsions. If you addition of this electron, after adding one electron, if you want to add one more electron, it must be how to supply the energy. Because it is already negative charge, it will repel each other. It means how to supply some amount of energy, then only it will releases. If you consider delta H is equal to, this is minus IE1, delta H1, delta H2 is equal to minus plus IE2, EA, electron affinity 2, electron affinity 1, if delta H3 is equal to plus electron affinity 3. This is the condition. If you take, what will happen if by addition of electron affinity 1 plus electron affinity 2 plus electron affinity 3 is greater than 0 or less than 0 or is equal to 0. By addition of these three, always it will less than 0. Always it is not greater than 0. Always it is greater than 0, because this is plus E, always electron affinity, always it is less than 0, because this is the negative we have to supply, this is positive, this is always negative. This option is correct. Combine of these three successive electron affinities, we get negative only. If you take in case of delta H, delta H1 plus delta H2 plus delta H3 get greater than 0, means it is positive, because these two positives are greater than compared to one is negative. Always it is greater than 0. This is less than 0. Next we have to discuss about the factors affecting the electron affinity. What are the factors? First factor is atomic size. First factor is atomic size. If you take bigger the size, if you take smaller the size, this attract more compared to this. If size is bigger, the attractions between this positive charge to negative charge electron is less. That's why if atomic size more, atomic size inversely proportional to electron affinity. If it is vice versa, whatever it may be, electron affinity is inversely proportional to atomic size. This is the equation. This is reciprocal of atomic size. If you take nuclear charge is directly proportional to electron affinity. Why? Because if it is more charge is there, if it is electrons there, more attacks, more it will accept, more energy will be released. That's why if nuclear charge increases, then it will atomic electron affinity will also automatically increases. Next, third one, stable electronic configuration. Stable electronic configuration. Stable electronic configuration. What is stable electronic configuration? Third one. If you take, for example, if you take S2, P3 or D5, one more S1, P3, P5, F7. If you take P6, D10, F14. These configurations is electron affinity is 0, because it will not accept the electron to stable configuration, because very less in this case, but also be 0, almost to 0, negligible, because stable electron configuration. That's why they say electron affinity is 0. What is the factors affecting the electron affinities? Atomic size. Atomic size is reciprocal of the electron affinity. Nuclear charge increases, electron affinity increases. If you get a stable electronic configuration, then atomic electron affinity is 0. This is the three factors which affect the electron affinity. if you take trends in electron affinity along the period and group, trends in trends of electron affinity. For example, if you take in case of period left to right, what will happen? Take period. For example, if you take period, different periods, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. In period, what will happen? Left to right, what will happen? Nuclear charge increases. Automatically, electron affinity also increases because directly proportional. As per expected, as according to expected, lithium is greater than, beryllium is less than, boron is less than, carbon is less than, nitrogen is less than, oxygen is less than, fluorine is less than neon. This is the expected, but it is wrong. What will happen? 1s1. What will happen? 1s1, 1s2, 1s2, 2p1, 1s2, 2p2. Electron configuration at 1s2, 2p3, 1s2, 2p4, 1s2, 2p5, 1s2, 2p6, 1s2, 2s2, 1s2, not greater, 2s2, second period. That's why 2s2, 2s1. This is second period. This is second period. This is second period. Start with second period. Expected like this because the period left to right, if nuclear charge increases, electron affinity will increases, but expected. What? Due to this is completely filled. This is electron affinity is almost 0. If you take, for example, neon is least. After that, what will happen? Exceptions. This is half filled. This is half filled. Nitrogen is less. Next, what will happen? What is the series? Next, lithium. Next, beryllium, boron is less than, carbon is less than, oxygen is less than, fluorine. This is the series. But in this case, lithium, beryllium and boron, boron and lithium. In this case, if by adding one electron, this is stable. By adding this electron, this is not stable. It is easy to accept. In case of lithium and lithium, beryllium also least it will come. This is in half filled, complete filled. That's why this is after neon, no nitrogen, it will get beryllium. Next after that lithium, then boron. But you have to compare these two, lithium and boron. This is lithium, by adding one electron it will get stable, but boron is not stable. But lithium will get more stable. That's why this is less compared to boron. Boron is least compared to lithium. Because it is easy to accept the electron, it will get more stable configuration. That's why this is release more amount of energy. But in this case, boron not like that, because one is 2p1 is there. Nuclear charge is there, but dominated the half-filled configuration. By adding one electron, it will get stable configuration. For that it will attract more compared to boron. This is the actually electron affinity series. Two exceptions are there. One is in case of neon, electron affinity is 0. In case of half field, it gets stable. That's why it not add the electron. In case of boron, is stable. Small size also affected. That's why this is getting more. Beryllium. Next, boron, lithium, carbon, oxygen, and fluorine. As per the series, it will. First of all, we have to discuss from left to right. Nuclear charge increases, electron affinity increases. According to the series, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, as expected. But due to the half filled and completely filled, and also some of the exceptions, because of that only, then it will change the series. Neon will give least, then nitrogen, then beryllium, then boron, lithium, carbon, oxygen, fluorine. This is the series as we find out the series of the electron affinity. In case of groups, group how it will changes. First of all, first we have to discuss with the group 17, then later we can. In case of group 17, groups what will happen from down to size increases, electron affinity will decreases. Size increases, electron affinity decreases in case of groups. This is the concept. But in case of group 17, what will happen? In case of group 17, fluorine, chlorine, bromine, iodine. Take. As per the series, fluorine is greater than, chlorine is greater than, bromine is greater than iodine. This is the series expected. But this is not wrong. Because what will happen? Fluorine is size is small, chlorine is somewhat more, but this is the bigger size. This is one more or some more bigger. What will happen? What is the definition of the electron affinity? It is the amount of energy released when by adding the electron, accept the electron towards in valence shell. The amount of release is called as the electron affinity, the gaseous isolated atom. But if the attraction is more attraction, more acceptance is more attraction, but acceptance is less in case of fluorine, because size is small. Smaller size, the acceptance of electron is very less, but in case of chlorine it will more, acceptance is more, and also the more attraction. Compared to chlorine, attraction is more, but acceptance is less, because due to the small size, by adding addition of electron, acceptance is very less, because size is small. Smaller size, smaller room cannot accept the person to inside, but attraction is more in case of fluorine. But in case of chlorine, what will happen? Acceptance is more, but attraction compared to fluorine is less. But in case of bromine and iodine, attraction will be very less attraction. By comparing these two, chlorine will be more electron affinity, because due to the acceptance and attraction. By comparing these two options, this is chlorine will be more electron affinity. Series is chlorine is greater than, fluorine is greater than, then again bromine and iodine. This is the correct sequence of electron affinity. If you take, I have explained one more. Compared to fluorine, chlorine is size is more. How to what is electron affinity? The amount of addition of electron towards the valence shell, the released amount is called as electron affinity in a gaseous isolated atom. That is common. But in case, two things we have to remember here in case of comparison of fluorine, chlorine. As per comparisons, by down the group, size will increases, the electron affinity will be decreases. That is the fundamental concept. But in case of fluorine, chlorine will be less as per expected, but chlorine will be the maximum electron affinity. Why? Because in case of fluorine, attraction will be more, acceptance is less. But in case of chlorine, due to small size, but in case of chlorine, attraction will be somewhat less compared to fluorine, but acceptance is more. That's why this chlorine will be having more highest electron affinity. But in this case, bromine, the attraction will be compared to very less. That's why down the group, the electron affinity will be decreases, but in case of fluorine and chlorine, chlorine will be the most electron affinity in the entire periodic table. Chlorine will have highest electron affinity. Highest electron affinity. This you have to remember. Now we have to discuss groups, different atoms. To take group 14, group 15, group 16, group 17. What is how we do? Carbon, silicon, germanium, tin, nitrogen, phosphorus, arsenic and strontium, oxygen, sulfur, selenium and tellurium, chlorine, bromine, iodine. If you compare these two, what will happen? Down the group, what will happen? Electron affinity decreases as per expected. But what will happen compared to this one? Compared to carbon will have as expected more, but in case of compared to carbon, silicon will be more, because second period I have already told you size and attraction both you have to consider in case of electron affinity. If you combine of these two, then silicon will be more electron affinity than nitrogen. Compared to oxygen, sulfur is more electron affinity. Compared to chlorine will be more electron affinity. But in case of this you have to compare to oxygen. In case of oxygen, this you have to remember exception. Oxygen is very less. Sulfur, selenium and tellurium. Oxygen is very less electron affinity. This one of the point. But in case of this one, we have to follow the trend. Silicon is greater than carbon is greater than germanium is greater than silicon. But in case of phosphorus is greater than nitrogen is greater than arsenic greater than strontium, as already have discussed. But in this case of oxygen is very less compared to in the group 16. This later I will explain why, because oxygen is very less electron compared to all these. As per trend, you have to after sulfur you have to come oxygen, but in this case in this group oxygen is very less. This your point you have to remember. Thank you very much. Now we are discussed about the electron affinity. Next we discuss about the after this electronegativity.